Here we have a problem. A space probe is launched from a spacecraft that's orbiting Mars. Here we see the position is given above, and here are a few things that are important that were given in the problem. We have the mass of the probe launched from the spacecraft. We have the initial position of the spacecraft in the first time interval. We have the initial momentum in the first time interval. We have the time interval. And then we have the net force. Initially, we're given here the first time and the second time. We used the change of time formula. We just subtracted the first initial time from the second time to have the change in time. That's where we get our 0.2 seconds from here that we're going to be using later in the problem. So here, our net force is given as well. And I think it's important to note that this net force is the gravitational force of Mars pulling on the space probe. And it's also taking into account the air resistance from the atmosphere that's going to be pushing against the space probe being pulled into Mars. So here, let's find the change of momentum. Let's find the change of position. Be advised that for educational purposes, I'm going to go beyond the necessary steps to find the change of momentum and to find the change of position in this problem. So please bear with me. So we're going to be needing to use these important formulas. We're going to need the momentum principle. We're going to need to know that the change of time times the net force is going to be equal to the final momentum minus the initial momentum. We're going to need to know the position update formula. We're going to need to know that the change of time times the average velocity is going to equal the final position minus the initial position. Okay. So here we see we have our momentum principle right here. We're going to first find the change of momentum. So here we have all of our information given in the beginning of the problem, and we're going to go ahead and solve for the final momentum. That's what we did here. So now that we have our initial momentum, we have our change of time, and we have our net force that's acting upon the space probe, then we can go and plug these into the formula right away. Now that we have our final momentum, we can go right ahead and subtract our initial momentum to find our change in momentum. That's what we do here. And this will be our change in momentum. Now, the second part of the problem asks us to find the change of position using the position update formula. So, one important note to know is that the problem tells us to use the approximation that our average velocity is going to be approximately our final momentum divided by the mass of our space probe. Whenever we go and work this out, our masses are going to cancel out, and we're going to be left with meters per second here. So now we're going to use our position update formula, and we're going to solve for our final position, because we already know our initial position, but we want to find our final position. So here we have our values for our initial position, we have our change in time, and we have our average velocity. Our seconds are going to cancel out, and we're left with meters. We're going to add these two vectors of meters together, and we're going to be given our final position. Now we're going to find the change of position. We're going to subtract the first position from the second position. And we see that our change of position in our short time interval of 0.2 seconds is only 35.8 meters in the x direction and negative 6.5 meters in the y direction. There we have it.